Okay, I'm not going to make this a very complicated video simply because we've already gone and tested a power supply in this sort of manner before. Remember the NCR 250 cash register? Same thing. Linear power supply, multiple voltage rails. We just wanted to see if the voltage rails were correct or if anything was going to blow up. But that was multiple voltage rails. There was a bit more self-regulating logic going on in there. This thing has none of that. It has one voltage rail, in fact. What we're looking at here is the power supply for an IBM Model 29 Keypunch. And this is a power supply, 120 volts goes in, and out of it comes 48 volts at 2.5 amps. This is not a complicated power supply. We have AC comes in, power switch, obviously, transformer, primary winding, secondary winding, because this is a ferroinductant transformer. I think I'm getting this wrong here. Anyways, the point is there's kind of two secondary windings. One of them goes to this AC capacitor here. The other side comes out as your reduced AC voltage. There's two diodes. You have this capacitor. You have a resistor that's sitting up there that basically acts as a load and a bleeder for this capacitor. And there's your 48 volt output. I've already gone, and this cap is 300 volts, 16 microfarads, and it tests okay. And there's not a lot that goes wrong with these besides this is actually from 1969, so this does contain PCBs. I won't be replacing it because it seems to test fine, and it's sealed. And this capacitor here, I've already gone and tried to do a reform on it, and it seemed to be okay. We were looking at about 25 microamps of leakage out of this. I think it's 5,000 microfarads, 50 volts, or 50 or 52 volts. It's rated basically a little bit above the 48 volts that it's going to run on. And of course there's a power switch up there. What I have wired up here, however, is my rig, which I can use to test linear power supplies in this fashion. You can't really do this with switch mode power supplies because once you get below a certain voltage, it just shuts down anyways. The first thing you see here is this weird little box, and this is the most not UL certified thing you will ever run into. 120 volts comes in on this line here, and these two banana plugs here are your AC. Really, this should be black for line and white for neutral instead of red for line and black for neutral. It's all I had available on hand. And it just terminates on these two banana plug spades, which can also be unscrewed, and you can actually attach wires or clips or whatever you want to them at the same time. To get to the output side of this, you just simply use a jumper banana plug. Or, in this situation here, I can actually tap in between here. This banana plug runs over here to my variac, which then runs back on this wire to the bottom side. Now the ground wire on this does not have the same thing. It always passes straight through with this green banana plug socket here, which is basically it's just a ground tap you can always work into. However, I can't help but notice on this power supply, some schmuck has cut off the ground pin. So, okay, that ground's not going to be all that useful. Instead, in this laboratory application, as I have this extra alligator clip cable here, and that goes to another earth ground tap that's on my bench here. So it is still grounded for the duration of this test. This ammeter over here, I just have clipped onto, I can have it here, I can have it here, of course I can have it up here again. I just want to see what kind of a load goes through it. These here are rated to burn out at around 10 amps. This massive power stat model F136 variac is rated for 20 amps, and the wall outlet's rated for 15 amps. So if anything's going to give, we're going to see it on here. Otherwise, it's going to explode on this power supply. Now, again, I don't like the idea of having to reach over the flaming objects that are also burning and exploding to reach my main power switch. So I have this little buddy right here. This is a Treadlite 7 amp rated foot switch. You push it on, you take your foot off, it turns it off. I use them as dead man switches because it's way better than just reaching for a power bar trying to unplug it. You back off, it goes off the switch. Anyways, I'm going to put that on the floor here. There we go. I'm going to turn on my multimeter, and this is going to give us the DC voltage of that capacitor. I'm going to turn on my ammeter, which I think you can see. Yes, you can just kind of see. Hello. I'm just over here. And now I'm just going to put my foot on the pedal, and we're going to see what explodes. And immediately I here have just under a volt. But I'm now going to start turning up the variac slowly. And we should start to see this voltage here increase. And we're still sitting at like 30 milliamps. So there we go, 20%. Going up on 5 volts here. Now I'm going to hear the auto transformer inside of the variac begin to buzz before this one starts to buzz. And we will find at one point at the voltage, the inductance of this transformer will kick in and this one here will stop buzzing. You probably won't hear it though because my microphone is not sensitive enough. Anyway, 7 volts, 8 volts, 9 volts, 10 volts. I have reformed this capacitor here up to 30 volts, which is what my bench supply could do, so it'll probably be fine. Keep going. Go. Oh, and now that's buzzing, and this has stopped buzzing. And we're now at 52 volts here. So, okay, the output is unloaded. That's okay, but now I'm only at like 60% here. So let's go all the way, and that'll bring us up to 110 volts. We're still consuming only about 300 milliamps over here, so we're still way under. And there we go. So 50 volts, so we're about 2 volts off without a load. The transformer seems okay. The diode seems okay. What I'm going to quickly do here is I'm going to turn it off now that we know it's not going to explode on us here. I can see that the resistor isn't open, and I tested that already. It's like 200 ohms. It's fine. I'm going to switch it over to AC volts because if those diodes have failed, we'd see an heavy AC voltage. And oh, I'm still in DC volts, that's why. There we go. Okay, we initially saw it, but once that was done, we're sitting at 0.1 volts AC and 50 volts DC. So we know that the diodes are good. It is doing its rectification. This power supply here has nothing else in it, so it's safe to say this power supply is good. It's as simple as that. Hope you enjoyed watching it, and until next time, have a good one.